Welcome to the first lecture on dyes. In the present lecture, we will discuss the introduction of dyes. We will also discuss the nomenclature and classification of dyes. But before we formally start the lecture, the question arises that what actually are dyes? If you look around yourself, you will see color in the living as well as in the non-living things. And then the question arises that why a particular substance or a particular fabric is looking red whereas the other is not looking the same color. So, with the help of the chemical composition of these fabrics or materials and on the basis of chemical composition of the dyeing material, we will discuss that how they show different colors. So, to formally start the lecture, we will first of all introduce what actually are dyes. We will then discuss the requirement from a good dye. Then we will discuss the nomenclature and classification of dyes. The classification of dyes is divided again into two categories. First on the basis of chemical composition and the other is on the basis of application. Under the category of classification of dyes on the basis of application, the first kind of dye we will discuss is acid dyes, then we will discuss basic dyes, azo dyes, we will then discuss direct dyes, mordant dyes, sulfur dyes, wet dyes, developed dyes, naphthol dyes, reactive dyes and pigment dyes. Now, to start with the introduction of dyes, dyes are the substances which are capable of coloring materials like fabric, paper, plastic, etc. A substance is called dye if it satisfies following conditions. The conditions are: it must have color, it should be capable of being fixed onto the fabric directly or indirectly with the help of the mordant. The color should be fast to light and resistant to water and soap. It should also be resistant to mild acids and alkalis. Dyes are the colorants which can be firmly absorbed onto the material to which they are applied by physical or chemical bonding. Pigments on the other hand consist of extremely fine particles of coloring matter suspended in liquid which form a paint film that actually bonds to the surface to which it is applied. So, basically among dyes and pigments, if you will look at, you will not be able to find out the difference because pigments as well as dyes are basically colored substances, but their method of application is different. Dyes are colorants which can firmly absorb into the material to which they are applied by physical or chemical bonding. A good dye must withstand the subsequent treatments like laundering, dry cleaning, etc., or environmental wearing like rubbing or exposure to light. This is the requirement from a good dye. The degree to which a dyed material can withstand such treatments and wearing is called color fastness. But it has been found that no dye or pigment is fast in all colors. Only a careful selection and formulation of dyes can result in a desirable dyeing and conform with the color fastness requirement. We will now discuss the nomenclature of dyes. There is no systematic nomenclature for dyes. Each dye has a trade name mostly given by the manufacturer. Thus, a particular type of dye may have more than one name because it may be manufactured by more than one trader. The shade of the dye is represented by letters. For example, the alphabet Y or G stands for yellow. The German word gelb actually means yellow and G has been taken from there. R stands for red. The German word rot means red, and B stands for blue, which has come from German word blau. When the letters are repeated, that indicates the intensity of the color. For example, if B is representing blue color, BB or 2B represents darker blue. The numerals like 2, 3 and 4 etc. indicates the intensity of the shade. Methyl violet 6B indicates a very deep blue tone, whereas alkali fast green BB is a greenish acid dye with a blue tinge. That means if it is 6B, the intensity of color is very high, whereas when it is BB or only 2B, that means the shade is not that deep. Now, letters sometimes have different meanings, as in some cases letter represent the class of the dye also. For example, D in alizarin, blue D, indicates that the dye is direct cotton color. S derived from German word Säure means acid. After the name of a dye indicates that the dye is an acid color. In some cases, the letter indicates the property of the dye. Like for example, letter F indicates the fastness of the dye towards sunlight and washing etc. Letter L indicates light fastness of the shade. For example, dyes like Basacril yellow 5GL, ketone fast yellow 2GL, benzo fast red 8BL etc. Here you can see that we are showing 5G means the color is very fast and L stands for the light fastness of the dye. Dyes having one chlorine atom are less reactive, so dye solution are to be heated for greater reactivity. Such dyes are called hot brand reactive dyes and are represented by letter H with their names. For example, Procyon H or Primactive H, where H represents the application of dye by heating since it has a chlorine atom in it. The solubilized VAT dyes are represented by the letter I. They are subdivided into groups like IK, IW and IN depending upon the temperature used for drying. The range of dyeing for IK, IW and IN groups of wet dyes is 20 to 30 degrees centigrade, 30 to 40 degrees centigrade and 50 to 60 degrees centigrade respectively. The letter NK indicates the normal and cold conditions of dyeing respectively. We have so far discussed the nomenclature of dyes depending upon the shades or colors they are producing or depending upon the intensity of color they have. Now, to avoid this confusion due to arbitrarily naming dyes, a color index has been prepared by the Society of Dyers and Colorists in UK and American Association of Textile Chemists in United States. Each dye is assigned a CI number, which is actually color index, consisting of 5 digits specific to that dye. The CI also assigns a specific name to each dye, which is based on the mode of action and base color of the dye or textile. For example, for a dye Indian throne, the CI number is 69800 and CI name is Wet Blue 4. The CI number of the dye chromoxane cyanine R is 43820 and its CI name is Mordant Blue 3. We will now discuss the classification of dyes on the basis of chemical composition. This classification is mainly of theoretical interest for the dye manufacturers and dye chemists who are interested in the chemical constitution of dyes. The method of classification, however, is very difficult because the distribution of whole range of dyes into proper groups is a tedious task. Some of the classes according to chemical structure have been given here. Here you can see these are nitro dyes. Nitroso dyes Accordingly, azo dyes, triphenyl methane dyes, they all represent a particular chemical composition. We will discuss about these dyes later on. In this type of classification, sometimes a particular dye may be grouped in more than one group. Moreover, groups like azo dyes and anthraquinone dyes may further be classified according to their nature of application to the fiber. Dyes have diverse chemical structures, and on the basis of their application, a molecule of dye may be bonded to the fiber in 4 different ways. These are covalent bond, hydrogen bond, ionic bond and van der Waals forces. The nature of bonding for a given dye depends on the chemical nature of the fiber, and on the basis of application the dyes may be classified in 3 different ways: on the basis of nature of fabric to be dyed, on the basis of intermediates from which they are prepared, and on the basis of chemical composition and structure of dyes. The last two methods are important. This kind of classification is useful to the dyers who are mainly concerned with the process of dyeing. This classification is more useful because it provides various methods of dyeing different fabrics with different dyes. We will first of all discuss acid dyes, which come or which are classified on the basis of the application on fiber. Acid dyes are the sodium salt of sulfonic acids or nitrophenols. They can dye animal fibers like wool, silk directly, but cannot dye vegetable fibers like cotton and linen, as the process requires a mordant. The fastness of acid dyes increases after the treatment with fixatives. These dyes are always applied in acidic solution. The dyeing process is reversible and may be described as seen here. This is the dye which is used in presence of acid. It is applied on the fiber so that the dyeing is done on the fiber. Acid dyes are water soluble anionic dyes containing one or more sulfonic acid groups or other acidic groups. For example, picric acid, Martier's yellow, orange 2, naphthol yellow, acid yellow 36, etc. Here this is the orange 2 dye, which is an acid dye. Now we will discuss basic dyes, which are water soluble and produce colored cations in solutions. They are mostly amino and substituted amino compounds, soluble in acids and made insoluble by making the solution basic. These are salts, may be hydrochlorides or zinc chlorides complexed with color bases. Like acid dyes, basic dyes are used to dye animal fibers like silk and wool directly, but not unmordanted vegetable fiber like cotton. They are also used to dye paper, polyacrylonitriles, modified nylons and modified polyesters. The members of this group are azo dyes and triphenyl methane dyes. The dyes applied onto the fabric by formation of salt linkage or ionic bond with anionic groups in the fiber. Now, another class of dyes is azo dyes, which contains at least one azo group. Azo group is nothing but this N double bond N bond present in the molecule attached to one of the two aromatic rings. They are produced on textile fiber, usually cotton, rayon and polyester, by diazotization of a primary aromatic amine followed by coupling of the resulting diazonium salt with an electron rich nucleophile, which is also called azo coupling. A variety of azo dyes can be obtained by proper choice of diazo compound and coupling reagents. We will now discuss direct dyes. Direct dyes are water soluble anionic dyes but are not classified as acid dyes because the acid groups are not the means of attachment to the fiber. They are used for the direct dyeing of cotton and regenerated cellulose, paper and leather. They are also used to dye union goods, which is mixed cotton and wool or silk, and to a lesser extent nylon fiber. Most of the dyes in this class are polyazo compound along with some stilbenes, phthalocyanines and oxazines. Now the modern dyes. Some dyes combine with metal salts, which the process is called mordanting, to form insoluble colored complexes, which are also called lakes. These materials are used for the dyeing of cotton, wool and other protein fibers. The fiber is first treated with an aluminum or chromium or iron salt and then contacted with a lake forming dye. Azo and anthraquinone derivatives are used for this purpose. The metallic precipitate is formed in the fiber, producing very fast color, highly resistant to both light and washing. The hydroxyl group attached to anthraquinone are capable of reaction with metals in the modern material to form modern dyes, aluminum lakes. Alizarin is the best known anthraquinone derivative as an example of a modern dye as shown here. This is modern red 11. The next category of dyes is sulfur dyes. These dyes are solubilized with the help of caustic soda and sodium sulphide, and the dyeing is carried out at high temperature with large quantities of salt, which help the color to penetrate into the fiber. Dyeing is followed by oxidation of fabric either by exposure to air or by chemicals. Sulfur dyes are applied to cotton from an alkaline reducing bath with sodium sulphide as a reducing agent. These dyes are water insoluble, but they are soluble in their reduced form and exhibit affinity for cellulose. These dyes are used for dyeing cotton and linen. They are low cost and are fast to light washings and acids. The actual structure of sulfur dyes are largely unknown, although it is considered that they possess sulfur containing heterocyclic rings. They dye by absorption, but on exposure to air they are oxidized to reform the original insoluble dye inside the fiber. Now we will discuss wet dyes. Wet dyes are water insoluble and cannot dye the fiber directly. These are solubilized by reduction in alkaline medium. This helps the dye to fix onto the fiber. Subsequent oxidation restores the dye to its insoluble form. The dye produced in this way has high wash and light fastness. The example of a wet dye is wet blue 4, which is also called indanthrene, which has this structure. Wet dyes are water insoluble but soluble in alcohol, chlorinated hydrocarbons or liquid ammonia. They are used for coloring synthetics, plastics, gasoline, oils and waxes. The dyes are predominantly azo and anthraquinone, but phthalocyanine and triaryl methane dyes are also used for this purpose. Perchloroethylene is the preferred solvent used for the purpose of dyeing. We will now discuss developed dyes. These dyes are formed by the use of developer. The substrate is first immersed in neutral solution with a dye base, usually colorless amines. This is then diazotized with sodium nitrite and acid in cold conditions. This is then added to alkaline solution of beta-naphthol or a phenolic compound which acts as developer. Dyes are formed on the surface of fiber. In case of naphthol dyes, these are nothing but azo dyes formed by the reaction of naphthols, that is phenolic compound, with diazonium salts. The fiber is first treated with alkaline solution of naphthol, which is then immersed in another solution containing diazonium salt. The two reacts to form deep red azo dye. These are used for dyeing cellulose fibers, but with modified process other fibers can also be dyed by this method. We will now discuss reactive dyes. These dyes contain reactive groups which combine directly with cellulose fiber. These are applied in alkaline solution or applied first and then the solution is made alkaline. Heat treatment helps develop different shades. Dyeing is followed by washing with soap to get rid of any unfixed dye. These dyes were originally used for dyeing cellulose, but nowadays also used for dyeing wool, silk, nylon, acrylics, etc. Now the pigment dyes. In true sense, pigments are not dyes, but as they have excellent light fastness, they are extensively used nowadays for coloring cotton and wood fabrics. They get fixed to the fabric with the help of resins. The dyeing process requires high temperature treatment. So with this we have introduced what actually are dyes. Then we have also discussed the requirement from a good dye. A good dye is one which gives the required color to the material, and also the color is fast to light and the weathering effect. Then we have discussed the nomenclature of dyes. In this we have discussed in detail the nomenclature used by the producer, that is manufacturers, as well as the nomenclature normally used for the purpose of dyeing, which has a color index and color index name. Color index has 5-digit number and color index name has a particular specification showing the details about the dye. Then we have discussed the classification of dyes on the basis of chemical composition and classification of dyes on the basis of application. We have not discussed the classification of dyes on the basis of chemical composition in detail. In the next episode, we will discuss all these classes of dyes like acid dyes, azo dyes or triphenyl methane dyes. We will discuss about their structure. In the present one, we have discussed acid dyes, basic dyes, we have discussed azo dyes. Then we have also discussed direct dyes, modern dyes, sulfur dyes, wet dyes, developed dyes, naphthol dyes, reactive dyes and pigment dyes. Now if you will look at all the dyes we have discussed so far on the basis of their application, you will find that a number of dyes, like for example azo dyes, we are discussing in a number of classes, and depending upon the nature of application, the same dye has been classified in different classes. So this is a very unique way of classifying the dyes for the purpose of dyeing by the dyers. With this method of classification, you will be able to understand various types of application of dyes onto the fiber or fabric or synthetic materials. In the next lecture, we will discuss the classification of dyes on the basis of chemical composition in detail, and we will be able to relate the classification on the basis of application with that of chemical composition. Thank you very much.